it's been called the biggest problem in physics. Why is space, why does even empty space have this energy, the cosmological constant, which, as I say, is unchanging and absolutely uniform? Where did it come from? Why is there a cosmological constant? So the standard model includes this. And because it's included, it's able to fit a huge range of data. So it's one parameter, but it explains, hundreds of thousands of observations. So it's a pretty good model. Now, Desi comes along and they said, our data doesn't quite fit the standard model. In the standard model, this cosmological constant is causing a universe to accelerate its expansion, but they find that the acceleration is not exactly as predicted by a cosmological constant. It takes a very weird form. So it was accelerating more in the past, and then apparently in recent epochs, that additional acceleration is going away. Okay, so it's not a model anybody dreamed up. It's not a theory anybody dreamed up. They're finding their data fits, and all they do is a fit. They don't have a theory. So they do a fit to it, and they find that they can fit it by assuming that the cosmological constant, which is one number, is replaced by two numbers, one of which is the value now of the cosmological constant, and the other, if you like, is the sort of rate of change in the past, as we look to the past of this cosmos. So they've got a two-parameter model, and they say it fits better.
So what's the bet?
The bet is the following. My colleague said he was sufficiently convinced by the data that he's willing to bet £1,000 that it's correct. However, I looked at the data. Now, the only way, their significance of their data is less than 4 standard deviations. It's not very significant. And they only get the 4 standard deviations, by using 3 different experiments, one of which is theirs, and the other 2 are not theirs. And these different experiments have different systematic errors. So if you combine 3 experiments with their own systematic errors, which are really difficult, these measurements are very, very difficult in astronomy, and you end up with something around 4 standard deviations, it's not very impressive. And particle physics has learned never to believe a result which isn't 5 standard deviations from a single experiment. They're using 3 experiments. And so anyway, I'm not convinced. So I said to him, look, what you're doing is proposing a fit. It's not a theory. You've got a 2-parameter fit, and you're saying this is better than a cosmological constant. You agree that this fit is compatible with, let's say, 1,000 theories. You don't even have a theory, right? As far as I know, there's not even one theoretical model. I'm sure people will come up with them, but as far as I know, currently there's not even one semi-plausible.
Quintessence?
No, it does the wrong thing. You see, so that's what I said, because in this fit, the lambda's bigger in the past than now. Quintessence goes the other way. So in quintessence, the field sort of rolling stops. And so the cosmological constant kind of settles, and you stick with it. In this fit, the cosmological constant was sort of big, I don't know, redshifts 3, 4, and then switched off today. It's a very puzzling behavior.
I get the idea. You're not a fan of this. You don't buy it.
No. So I said there's 1,000 models that would fit your data, and there's one model that fits one standard model. So I'll bet you £1 against your £1,000.
And he's willing to take that.
No, he hasn't accepted that, but he should.
Well, it depends on how certain he is.
Well, he's not willing to bet £1,000 against one.
If he's 1 to 1,000.
Right. So I would say the cosmological constant is a really well-motivated theoretical construct. And it fits pretty well, okay? He's saying an ad hoc two-parameter fit fits better, I'm not impressed. But maybe it's right. I have the utmost respect for the observations. They are going to improve. And if it reaches more than 5 or 6 or 10 sigma, I will have to accept it. So that's great. This controversy is very good for the field.
Just speaking of bets and certainty, I was speaking with Neil deGrasse Tyson, and he said about how there's UAPs in the sky, and are they aliens, are they UFOs? And he thinks it's a 1 in 100 billion chance that they're aliens. So I said, okay, if that's the case, I will put up $1,000 and you put up $1 million, and that should be vastly in your favor.
Yes.
And then he's like, no. I'll put up $100 to $10 or something like that. I'm like, well, then that's expressing you're not as certain as you claimed.
Right. I did this myself, actually. I was a volunteer teacher in Lesotho in Southern Africa before going to university. And I had a little motorbike. Now, all the villagers used to tell me that there is magic. There were, there were witches and people who did things at night. And there's something called a tokoloshi, which is a magical person you make out of various herbs and things, and it will go and kill somebody you want it to kill. So they told me all these stories, which they genuinely believed. And in fact, even the nuns in the convent believed it as well. And so I said, okay, I have this motorbike. You show me one piece of real evidence for magic, and you've got my motorbike. Okay?
Yes, exactly. So you were willing to put your money where your mouth is.
Absolutely. I'm always willing to do that. Frankly, with this bet on the Desi result, if pressed, I would put £1,000 against it. I think there is too much wishful thinking. It's very tempting as an experimentalist to believe that you've discovered something fundamental and shocking. And that's a bias which is very, very difficult to, and again, I'm not holding anything against these particular experimentalists, but I think that is a bias which, they would love. As I pressed him, in fact, this is what he said. He said, look, we better hope this is real, because if all there is a cosmological constant, then the field is dead. Meaning that there's kind of no point in doing any more observations because the answer is so simple, because you've solved it.
Uh-huh.
But I have the opposite point of view, that if the observations turn out to be simple, it is putting right in our face that we don't understand. We don't understand the Big Bang singularity. We don't understand this mysterious future of the universe dominated by cosmological constant or dark energy, whatever you want to call it. We don't understand the arrow of time. These foundational questions about the world. There's plenty to do. We don't need a glitch in an experiment, to tell us that we don't understand what's going on. It's obvious we don't understand.
Yes.
So I take the opposite point of view. If these experiments home in on an extremely simple model, that's our best hope. That's our best hope, because if things are simple, then they may be comprehensible. Einstein discovered general relativity on the basis of experiments done over the previous 300 years, which showed that objects of different composition and masses fell at the same rate under gravity. And he suddenly realized, this implies that they're all moving in the same arena, because they're all falling in exactly the same way. So maybe there's something like a curved space-time, which causes them to move through it, independent of what they're made of. And that was his basic clue, which led him to general relativity. So I think the simpler things get from the point of view of observations, the better it is for our eventual understanding.
Okay.
So, this is a purely emotional, point of view. I'm not saying one is right or wrong, but my point of view is that the simpler the observations are, the more likely it is that we're going to understand all of them.
The Economist covers math, physics, philosophy, and AI in a manner that shows how different countries perceive developments and how they impact markets. They recently published a piece on China's new neutrino detector. They cover extending life via mitochondrial transplants, creating an entirely new field of medicine. But it's also not just science. They analyze culture, they analyze finance, economics, business, international affairs across every region. I'm particularly liking their new Insider feature. It was just launched this month. It gives me a front row access to The Economist's internal editorial debates, where senior editors argue through the news with world leaders and policymakers in twice weekly long format shows. Basically, an extremely high-quality podcast. Whether it's scientific innovation or shifting global politics, The Economist provides comprehensive coverage beyond headlines. As a TOE listener, you get a special discount. Head over to economist.com/TOE to subscribe. That's economist.com/TOE for your discount.